Question 11. A rectangular building with sides 50 metres and 100 metres long has a flat roof on top of it. The roof has a mass per unit area of 100 kilograms per metre squared. The walls are 10 centimetres thick and can take a maximum stress of S max, which depends on the material of the wall. The values of S max of 5 building materials are, and then, so here are the values. Which materials could be used so that the walls will support the building, assuming that the mass of the walls is negligible. Okay, so first we want to find the area of the roof. So it looks something like this. Sorry for the bad sketch, I'm on a tablet. So we know this is 10, this is 100, this is 50. So the area of the roof will be 100 by 50, which equals 5,000 meters squared. And then we know that the mass per unit area is 100. So we know that the mass of the roof will just be this times 100, which is 5,000,000, so 500,000 kilograms. And then we know that we need to find the force of the roof, which is the weight, which will just be this times 10, which will be 5 million newtons. And we know that stress equals force over area. So we need to find this area here. So this will be 10 centimeters, which is 0.1 meters. I'll write that out. So we know it's 0.1 times by 50 times by 2. Added on to this is 100 here, but we're taking away these 0.1 sections. So this will be 98.2 times by 0.1 times by 2. So if we factorise this out, we have 0.1 times 2 times 50 plus 98.2. So we can actually approximate this 98.2 to 99.2 even, because it's basically the same number. So we have 0.1 times 2 times 150, which is 330 meters squared. And this is newtons per millimeter squared. So this is the conversion factor is between a meter and a millimeter is 1,000, but when it's meters squared, it's 1,000 squared. So we know this is 30 times 10 to the 6 millimeters squared, which is 3 divided out by 10 times this by 10 times 10 to the 7 millimeters squared. So we know that the stress it can take, or the stress it is taking, is 5 times 10 to the 6 over 3 times 10 to the 7. Actually, if this was 30 and this was 6, that'd be easier to work out, because we know that 5 over 30 is 1 over 6, simply. And 1 over 6 is, half of a third, so 0.333. Half of that is 0.1666, I think, but just around 0.17. So that's the stress that the walls can take. So if we look up to this, we can see that these are all much bigger than it. So any of the materials above can support the building.